In chemistry, a neutralization reaction can be defined as an acid and a base reacting to produce a salt and water. The reaction lessens the alkaline and acidic properties in each substance. Bases are chemical compounds that are soapy and turn red vegetable dyes blue if they're in solution. They have a pH of 7.1 to 14. On the other hand, acids are chemical compounds that are corrosive and turn blue vegetable dyes red. They're commonly recognized because of their sour taste. They also have a pH of 0 to 6.9. Substances with a pH of 7 are considered neutral. Neutralization reactions commonly take place in water. The fixed quantity of acids and bases for this type of reaction is one of the earliest examples of chemical equivalence. The first attempt at the interpretation of acid behavior was by Antoine Laurent Lavoisier at the end of the 18th century. He thought all acids contained oxygen. In 1838, a German called Justin von Liebig first defined an acid. He said that an acid is a compound containing hydrogen in a form that can be replaced by a metal. At the time, bases weren't further researched. However, as time passed, the definition was changed to that acids and bases are simply substances that respectively give rise to hydrogen and hydrogen ions in an aqueous solution. This definition was accepted for the next 30 to 40 years. In an effort to prevent the death of aquatic organisms such as fish, sanitary engineers and operators of water and wastewater systems have been studying the use of vitamin C to neutralize chlorine in the water. Because high levels of chlorine has the potential to harm animals, wastewater operators must neutralize the chlorine before releasing it into lakes, rivers, and/or streams. Currently, many methods are using the chemistry of a neutralization reaction to neutralize the chlorine. For example, a passive method is to allow sun and air to work over time to neutralize the chlorine. While this is an easy and inexpensive way, it works slow. A faster method is to introduce more chemicals into the equation. Sulfur can also be used to dechlorinate water. But caution is essential in this scenario because some sulfur compounds are hazardous as well. Although it works fast, this chemical method is much more unappealing than the passive method because two studies, done by Hall in 82 and Rain in 92, suggest that sulfur-based dechlorination still poses a threat to aquatic species. Vitamin C is a newer method that is being studied to help the wastewater project. In this, two forms of vitamin C, ascorbic acid and sodium ascorbate, neutralize the chlorine. Unlike the sulfur method, neither is hazardous, so it's not toxic to aquatic life. Neutralization reactions have many practical uses in the real world. They are used to treat excess gastric acid in the stomach by ingesting sodium bicarbonate or another alkali agent such as an antacid. They reduce the pain of insect stings. Bee stings are neutralized by an alkali and wasp stings by an acid. Nettle stings can be neutralized by alkalis that are found in dock leaves. Furthermore, they are used in environmental cases to control and reduce damage a toxin may have on its environment. In this case, neutralization is used because the salts produced in the reaction are generally less toxic. It's also an important step to reclaim previously mined land. Since mining leaves the land acidic, it must be neutralized with lime or calcium oxide. Moreover, it can help the growth of plants. Because acid rain leaves the soil slightly acidic, which, for some plants, stops the growth because their ability to take in nutrients and minerals from the soil is affected by the pH content. It can be neutralized by an alkali, therefore helping the growth of plants. Neutralization reactions are used to prevent harmful viruses. They work like antibodies which are released from the white blood cells that go through neutralization reactions to fight off infections. In terms of creating a new medicine, scientists are developing ways to study the encoding of genes to prevent and treat retroviral infections like HIV. If this works, new vaccine will grant the patient longer-lasting immunity. Not only can this help human patients and doctors, but it can also aid in the veterinarian vaccines.